3b, the directions were the same. What are the possible number of zeros that you can have in a fifth degree polynomial? So the maximum number of zeros we could have, we could cross the axis 5, 4, 3, 2, or 1. But because it's odd, it must cross somewhere. If it's an odd function, it has an even number of turning points, so it could be 4, 2, or 0. Our real zeros we're going to have to factor first, so just like we did in the other one, g of x is equal to 3x to the 5th plus 11x to the 4th minus 20x cubed. The x cubed could be factored out of all of them, so 3x squared plus 11x minus 20. And then we should see if this 3x squared factors again, the 3x squared plus 11x, so there's a good chance that this will factor again. 3 is prime, so all I can use is 3x and x. The signs have to be different, so they must be plus and minus. So one of them's got to be plus and minus. I'm not really sure exactly which one. I'm going to put the plus there and the minus there, and the factors of 20 that stood out in my mind were 5 and 4. Now if you place the 5 here and the 4 there, your outside and inside factors work out just perfectly. So that's going to give you a positive 15x. And then minus 4x, and that gives you 11x. So that's what we want to see there. So there's the factorization of it, which means that I have the factored form already done. Now I'm going to work on finding the zeros. So what are the inputs that create an output of 0? Well, for this x, if x is 0, is 1. For this one, we had pretty good success on this, but if you have trouble, set this equal 0. What will make this factor equal to 0? That's when 3x is equal to a 4. And that's when x is equal to a 4/3. So that's my 0 coming out of this one, 4/3. And this one's a little bit easier. It's just a -5. So our zeros are 0, 4/3, and -5.